Welcome back. We're in Khan Academy under Algebra 1, Quadratic Functions and Equations. We're looking at the skill number of solutions of quadratic equations. Here's the first problem we've got up. F of x equals 3x squared plus 12x plus 5. And their question is, what is the value of the discriminant of f? A discriminant in a quadratic function is part of the quadratic formula. So if you have a quadratic function like this, ax squared plus bx plus c, which we do, we have a constant times x squared plus a constant times x plus a constant. So we've got those constants, and we've got an x squared, an x, and an x to the 0 power term. When we have a function that is a quadratic function like this, then if you set that function equal to 0, it is always going to be true that the x values, or the numbers that make this equation true, will be the numbers you get from the quadratic formula, which you just take the constants they gave us, 3, 12, and 5 in this case, and put them in for their appropriate spots. So a is 3, b is 12, a is 3, and c is 5 in this case. Okay, so that gives you zeros of the function. Zeros are where the function crosses the x-axis, because zeros of a function, the function is giving you y values. For whatever x you put into the function, it's giving you a y value. So if we're finding out where the y value is 0, that happens on the x-axis. Fair enough. So the discriminant is part of the quadratic formula. It's right here. This part right here, just the stuff under the square root, is the discriminant. We'll write that. The discriminant is b squared minus 4ac. It's called a discriminant because it helps us to discriminate, or to discern, or to decide how many zeros there are for the function. So remember, this is asking us what is the value of the discriminant, but it's under the topic number of solutions. Okay, so think about a parabola. You could have a parabola that crosses the x-axis at 1, 2 spots, or maybe you have a parabola that just touches it once at the vertex, or maybe you have a parabola that doesn't touch the x-axis at all. That could happen by opening up and having the minimum value above the x-axis, or it could happen by opening down and having the maximum value below the x-axis. So there could be no zeros, there could be 1 0 if the vertex is on the x-axis, or there could be 2 zeros if it crosses twice. Okay, so how does the discriminant help us? Well, think, if you will, for a moment about what the quadratic formula is doing. It's giving us possibly as many as 2 solutions. That's because we're taking some number and we're going to add another number, or we're going to subtract another number. So we start at some number, negative b over 2a, and we add to it, or we subtract from it, and that gives us possibly 2 more values. Okay, so what we're adding here, or subtracting, moves us left or right. Well, b squared minus 4ac could be a positive number. If b squared is greater than 4ac, when we subtract, we'll get a positive number. We know that if we take the square root of a positive number, we get a real number out of that. Something like the square root of 4 is 2, or the square root of 81 is 9. But what if b squared was the same number as 4ac. If it was 9 minus 9, for example, well then this would be 0. And if you add or subtract a 0 from something, you don't change its value. So then you would only have one solution for x. But what if b squared is smaller than 4ac? If I subtract something like 4 minus 9, I get negative 5. There's no real number that is the square root of negative 5. The square root of a negative number is an imaginary number, but that will come into play someday, but for right now, that would mean we'd have no zeros. That would be the case like this, or like this, where we don't cross the x-axis at all. Okay, so then what we're going to see in this problem is all we have to do is identify the discriminant. Well, here's the discriminant. It's negative b, it's b squared minus 4ac. That's the only thing that you look for. That's what the discriminant is. It's this part of the quadratic formula. So in this case, b is 12, a is 3, so 4 times 3 times c is 5. 12 squared is 144. 4 times 5 is 20. 20 times 3 is 60. And I will now solve for that. 144 minus 60 is 84. So our discriminant is 84. How many distinct real zeros do we have? Well, I'm going to be adding or subtracting 84 to some other number. That's going to give me two different answers for x. So I have two different answers for this function equaling 0. So I'm going to put that there will be two distinct real number zeros. And we'll go to the next one. This time they give us a graph. Is the discriminant of f positive, 0, or negative? Well, let's think through that again. It's hitting at 2 points. We just saw on the last one that the discriminant was positive, so we know it's positive. But let's list out what happens. If the discriminant is positive, we'll make a little chart here, then there are number of zeros, then there are two real zeros, because we're adding and subtracting to some other number to give us solutions. There will be two solutions, okay? If the discriminant is 0, that means when I add and subtract or subtract 0, I'm not changing the number, so there will only be one solution. And if the discriminant is negative, I get an unreal, or I get an imaginary result, so I don't get a real result. I have no real result, so there'd be 0 real number solutions. So we can use that chart to figure this out and figure problems like it out. So in this case, we see that there's two real solutions, so the discriminant must be positive. Next question, what's the value of the discriminant? Remember, the discriminant is only b squared minus 4ac out of the quadratic formula. In this case, b is negative 10. A is 25. And c is 1. So negative 10 squared is 100. 4 times 25 times 1 is 100. So the discriminant is 0. And if the discriminant is 0, we have exactly one x-intercept, or exactly 1, 0 for the function. Is the discriminant of g positive, 0, or negative? Once again, it's positive because we have two real intercepts with the x-axis. And we're done with that set, but let me just show you over here on Desmos, which is a free online graphing utility that you should use and take advantage of. I have a function that I've defined as f of x equals ax squared plus bx plus c, so it's in this standard form. And right now, a is 1, so it's x squared. B is 0 and c is 0. So this function is the parent function for a quadratic. It's just f of x equals x squared. And as you can see, it hits the origin at its vertex. So, using what we just talked about, if the discriminant is b squared minus 4ac, in this case, b squared would be 0, and 4 times a times c would also be 0, so your discriminant is 0, and we have a parabola with one x-intercept. That's what always happens. Okay? But what happens if we were to increase c, right? If we've just added to the function, the whole function shifts up, or it translates up by 1 unit. Now we don't have any zeros. Let's see what happens with our discriminant. Our discriminant would be b squared, which is 0, minus 4 times a times c. 4 times 1 times 1 is 4. So 0 minus 4 is a negative number, and we have no real solutions. But what happens if we shift our function down? So now we have 2 real x-intercepts, and let's confirm that our discriminant will be positive. So b squared is 0 minus 4 times a times c. 4 times 1 times negative 1 is negative 4, but I'm subtracting negative 4, which gives me a positive 4. So if my discriminant is positive, I have 2 real solutions, 2 zeros of the function. And we're done.